Okay, so we are still talking about the types of like what we can get, right? When we do some chance experiments, the outcomes. And with our outcomes, we know that they're the sample set, all the possible outcomes. That one's when you do a sample set, you're not worried about what the chances are of rolling something or flipping a cup and getting something. Okay, we just want to know what possibly could happen. So in this example here, it says the sample space, there's the phrase we're working with, for the paper cup toss was on its side, right side up, and upside down. The outcomes of the experiment are equally likely to occur, and each of the probability of each outcome is equal. So what that means is it's not like the cup isn't like weighted a certain way, so it's going to fall one way or the other, something like that. Toss the paper cup 30 times, record the results in the table. Okay, so the results are so we pretended that we did this already. Except I see I missed one for some reason. That's supposed to be on its side. Okay, so we're going to use these outcomes that you can see here to answer these questions. So it says, using the results of your experiment, what is your estimate for the probability of a paper cup landing on its side? So remember our old terminology, not really old, but the last we were using probability terminology. So the probability of the outcome being on its side. Okay, so remember probability is how many times it actually happens over the total. So if you count on its side, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 happened 19 times out of the total number of times. Well, how many times did we already do this experiment? 30. So we have 19 out of 30. Okay. And you can leave it like that. I don't think I have my calculator up here. My calculator app. We can divide 19 divided by 30. Okay, and we get 0.63, right? So we can say it's approximately equal to 0.633 or 63.3%, something like that. Okay? So probability of any of these ways is all right. So that's a probability that's going to land on side. Okay? What's the probability that now it lands upside down? So we're going to take probability of the outcome being upside down. And then we do it. Let's see here. 1, 2, 3, 4. 5. Okay, so probably upside down, it's going to happen, it happened 5 times out of, again, the total of 30, which reduces down to 1/6 or 0.16 repeating. So you could say that's approximately equal to 0.16666. No, I won't do it that many times. I'll just say approximately equal to 1.66 or 16.6%. Anything of those. Okay. So obviously the probability is not as high as it landing on its side. Now, again, I want you to think of the other work we did with percents, right? What is the probability that lands right side up? Do I need to count? Well, if there's 30 total, 19 of them were taken care of on that side, plus another 5 more, that's upside down. So that would be 24. How many should be right side up? 6, right? So you don't really have to count because again, it's like tell that 100%. If you know what part of it is, what are you left with? Now, if you want, oops, don't do that. Go all the way back to the beginning and make yourself dizzy. If you want, you could count them still, just to be sure, which I tend to do. 1, 2, 3, 4, 5, 6, which we said. Okay, and 6 out of 30, that reduces, right? 6 goes into itself 1 time, 6 goes into 35 times. 1/5. or 0.2, which would be, if you move it over 2 times, 20%. Okay. All right, so based on results, do you think that the 3 outcomes are equally likely? So think back to equally likely. Remember, that's 50-50 chance. So if we basically have 20% or 16.6%, that's pretty close, but then this one is 63.3%. So based on our results, are they equally likely? No. No, not equally likely based on our results. And I'm throwing that in there because could we run this another time and get 10, 10, and 10? Sure. Or 9, 11, and 10? Sure. Could we run it sometime and get 28 on its side and 2 upside down and null right it up? Yes. Okay. So that's the risk with probability and chance experiments. You're going by what data you've collected. Okay. And there really is no necessarily right answer. The more tests you run, though, the closer probably will get to something you would expect. Okay, so let's look at a few more examples. Using the spinner below, answer the following questions. Are the events spinning and landing on 1 or 2 equally likely? So here's section 1, here's section 2. Are those two, and again, if it's a spinner, spinning around here, right? We're spinning either direction. Are they equally likely? Yes. Why? The sections are equal, or the same size, right? That's the other. Okay. This one are the same size. But what about 2 and 3? Are they equally likely? No. Okay. 3 is bigger than 2. Now, it doesn't mean that 3 will land more often, okay? But it has a more to land in to be considered a 3, right? So how many times do you predict the spinner will land on each section after 100 spins? So we have section 1, section 2, and section 3. Now remember what we've talked about in the past. In the last lesson, we could say if you found the probability, you can multiply by the number of times it happens and make a prediction about what's going to happen in the future, right? But that was equally likely. These two are equally likely. This one is not, okay? So let's maybe start with the 3. If I look at the circle right here, right? Oh, this is bad, okay? But all of this over here, that's half the circle, isn't it? Doesn't this cut it right in half? Okay, so it's half of it over here. So if it's 100 spins, what do you think half of them will be? 50. So now we have this half over here, and it's broken down into 2 sections. So if I have 50 other spins that we think are happening over here, this would be 25 and 25. Now, that's a prediction not based necessarily on what it has happened in the past, but on the size of the sections. All right, so now if you look at that one, okay, let's compare that to our last example. Draw a spinner that has 3 sections that are equally likely. 3 sections that are equally likely, okay? So here's my circle, okay? And if I want 3 sections, to the best of my ability, nope, I have to think about how I want to draw this here, right? Let me start over. Let me come straight down here. This is not easy for me. And go that way. And then squint, okay? There we go. We're pretty close. It's not perfect, but we're pretty close, right? How many times do you think the spinner will land in each one of these sections if they're equally likely? Okay? If there's 100 spins. Well, if we take 100 and we divide it by 3, We get 33.33 repeating, right? 33.3 repeating. So we'll say approximately 33 times each. Okay, so again, in our summary here, an outcome is the result of a single observation. The sample space is the set of all the possible outcomes. And the outcomes of the experiment are equally likely to occur if the probability of each outcome is equal. Kind of like in this circle, whereas this circle up here, not so much. Okay, so again, we're just keep building our knowledge of probability and chance experiments.